So yesterday at the plenary presentation and also published last night in Cancer Cell, David Russler-Germain presented our work doing single-cell profiling of large B-cell lymphoma. This was a collaborative effort between MD Anderson and Washington University in St. Louis, and we collectively put together a set of 232 biopsies that we profiled by single-cell multiomics, which enabled us to comprehensively profile both the immune and the non-immune microenvironment of a large series of both newly diagnosed and relapsed refractory large B-cell lymphomas. So by putting together this atlas of different cell types in large B-cell lymphomas, we managed to discover three reproducible underlying microenvironment archetype profiles that we call LymphoMAPs. The first profile is largely deplete of T cells and is characterized by high frequencies of cancer-associated fibroblasts and tumor-associated macrophages. We call that the FMAC subtype. There are two subtypes that have high frequencies of T cells. One that looks a bit more like a normal lymph node microenvironment, characterized by stromal cells like follicular dendritic cells and marginal zone reticular cells that provide a supportive microenvironment for T cells. And so the T cells are a healthier, naive and memory cell phenotype and also CD4 biased. And we call that the lymph node archetype. The second T cell rich archetype is more inflamed. It doesn't have those supportive architectural cells that provide the cytokines for T cell health, and is instead characterized by high frequencies of exhausted CD8 T cells together with superactivated macrophages. We call that the TEX archetype, short for T exhausted. So we evaluated these different archetypes and their association with a lot of different clinical characteristics. There's a lot of detail of those in the paper. What we focused on in the plenary presentation last night was the association with CAR T cell outcomes. You can imagine, based upon the biology of the different microenvironment archetypes and even prior associations between CAR T cell outcomes and microenvironment, for example, associations with macrophage compartment, that there would be associations with outcome. We saw that in our own data set and also in the ZUMA-1 data set, but the largest validation series that we had was the ZUMA-7 data set, which was the large phase 3 randomized study of axi-cel compared to standard of care chemotherapy with autologous stem cell transplant in second-line large B-cell lymphoma. So we leveraged the existing gene expression profiling data from that study, and we developed a classification algorithm that we call LymphoMapper, which is also a publicly available tool now, in order to classify those samples into the three lymphoma microenvironment archetypes. And then we compared the axi-cel arm to the standard of care arm within each archetype. What we found was that while the lymph node archetype patients did very well with axi-cel, with a highly significant benefit for axi-cel over standard of care, the FMAC archetype patients, which have a T-cell depleted microenvironment, did less well, but they still significantly benefited compared to standard of care. And the TEX archetype, that has a highly inflamed microenvironment characterized by exhausted CD8 T cells, had no significant benefit for axi-cel over standard of care. So we're excited about these findings for a couple of different reasons. One is that we think that this is going to be a useful predictive biomarker for selecting patients that are most likely to benefit from CAR T cells alone, but also the underlying biology gives us several opportunities in order to intervene in a biologically rational way in order to improve the outcomes of patients, either in combination with CAR T cell therapy or as alternatives to CAR T cell therapy. And so we're going to explore this prospectively using LymphoMAPs to select patients into sort of a basket trial in which we're either combining with CAR T cell therapy plus, for example, blocking interferon gamma with an interferon gamma blocking antibody or checkpoint blockade in the TEX archetype.